All right, Trig Lesson 4, Solving a Triangle. The objective here is that you can solve a right triangle using trigonometry, the Pythagorean theorem, and the sum of the angles of a triangle. All right, so solving a triangle means finding all of the missing sides and angles. We have a whole bunch of tools in order to do that. Our right triangle twos would be trigonometry, which is SOHCAHTOA. If you know two sides and you want to find an angle, you can do that with SOHCAHTOA. If you know an angle and a side and you want to find another side, you can do that also. The Pythagorean theorem will allow you to find a third side given the first two. You need to set up the a squared plus b squared equals c squared. And the sum of the angles of a triangle is 180 degrees. If you know two angles, you should be able to find the third. All right, there we go. In order. All right, so you're supposed to draw this example and think about which tool you would use to find theta. All right, here's theta. We are given the adjacent side as well as the hypotenuse. In my head, that's going to be a ka, which is cosine. So, cosine of theta equals 6.45 divided by 12.85. Again, to get rid of the cosine, we're going to take its inverse on both sides. And what the cosine does, the inverse cosine will undo. So on the left-hand side, we have just plain old theta. And then we have a calculator problem. To take the inverse cosine, so that second cosine, or if you're on the CX, just hit your trig functions and go to inverse cosine. And then 6.45 divide by 12.85 should give us approximately 59.87 degrees. All right, 59.87 degrees. We've just done that. So now we want to find beta. Again, 59.87. I know that I already have a right angle here, so I need to have my second two angles, theta and beta, add up to 90. So beta, I know, is going to be the 90 minus 59.87, which should give us 30.13 degrees. If you want to go the full Monty, we know that a triangle is 180 degrees. We would subtract off the 90 and then subtract off the 59.87, and that would also give us the 30.13 degrees. All right, continuing on. What tool are we going to use to find the length of BC? Well, we now have a 59.87. We're still talking about the opposite side from 59.87, and I would probably use the hypotenuse, although you could use the adjacent side. So we would have the sine of 59.87 equals the opposite side over 12.85. To get rid of the division, we would multiply both sides by the 12.85. Those would cancel. The opposite side would then have to be that 12.85 times the sine of 59.87, which should be 11.11. I think that's probably centimeters, but it doesn't tell us, so we'll have to float with that one. Now, there is a second option. Since we already know both sides, we could simply use the Pythagorean theorem. A squared plus b squared equals c squared. We have the hypotenuse, so we would have 6.45 plus b squared equals 12.85 squared. So b squared would equal 12.85 squared minus 6.45 squared. If we substitute those values into the calculator, we should end up with something like 653.0256. To get b not to be squared, we'd have to take the square root of both sides. And we would still end up with 11.11, except that's an example 2, so that's actually wrong. Restart. The 653 was from the second problem. So what we have actually with that 12.85 squared minus 6.45 squared is 123.52. Again, after that one, you might want to check my math. And then the square root of that would give us the 11.11. I think we're good there. Let's continue on. All right, so example 2. Solve the triangle. So we're looking for all of the missing values. So we're looking for beta, we're looking for the hypotenuse, and we're looking for side AC. I'm going to call that x for the time being. In this problem, they give us 25 first, so I'm going to just take that 90 that the two acute angles should equal and subtract off the 25, and that will give us a 65 degrees. So we have a 65 degrees for beta. All right, and then we have to go to finding lengths of sides. All right, so we have from 25 degrees, which they gave us. I would usually use the value that they give me in case I made a mistake in subtracting. If you're confident with that, it doesn't make a big difference if you use the 65 or the 25, but I would use the one that they give me. So opposite, let's go to adjacent. So that would be tangent. So we have tangent 25 degrees equals the opposite side, 10.8 over the adjacent side, that's x. Again, we have to solve that. We can multiply both sides by x. Those cancel. We have x. Tangent 25 equals 10.8. Divide by tangent of 25 on both sides. Those cancel, and we would have x equals about 23.16. Having found x equals 23.16, we can do one of two things. We can either use the Pythagorean theorem, 23.16 squared plus 10.8 squared equals the hypotenuse, or side AB, squared. If we do that, we end up with that AB squared equals the 653.0256 that I gave you last time. Then take the square root of both sides, and we'd have side AB approximately equal to 25.55. If you're just as comfortable with the trig at this point, you could use the sine of 25 equals 10.8 over that AB, or you call it the hypotenuse or whatever other variable you'd like. Again, I'm going to multiply both sides by AB, then divide by sine of 25. Again, those are canceled, so I'm dividing by the sine of 25. And I would have AB equals, again, those are canceled, that's what's leaving just the old AB. And then 10.8 divided by sine 25. It's going to give us that same 25.55. All right, so we have effectively solved the triangle. We have the hypotenuse, we have side AC, we have angle beta. There we go. Let's go to third example. Again, here we're not going to get either of the two angles. We'll have to do the sides to get those. Let's do the sides first. I'm going to do the Pythagorean theorem. Again, this y value is the hypotenuse, so we would have 5 squared plus 12 squared equals y squared. That gives us 25 plus 144 equals y squared. That's y squared equals 169. Square root of both sides. Y equals 13. If you remember Pythagorean triples, the 5, 12, 13 is a pretty common one. That might be something worth putting in the memory banks. To go for the angles, again, I'm going to use what they gave us, which is the 5 or opposite from theta, and the adjacent from theta. Opposite over adjacent is tangent, so I would say tangent of theta equals 5 over 12. I will have to take the inverse tangent of both sides to get theta by itself. Again, inverse tangent and tangent undo each other. So inverse tangent, tangent undo each other. We have just a theta left on the left-hand side. We take the inverse tangent of 5/12 on your calculator. And that's going to be something like 22.62 degrees, which makes some sense because it's the smaller of the two angles, alpha and beta, and 5, which is opposite that smaller angle, is the smaller side. And then once we have that angle, I'm going to simply take 90 minus that angle to find beta, which is going to end up somewhere in the like 67.38 degrees, if I'm not mistaken. So we have beta, we have theta, and we have the hypotenuse 13 already. Let's move on to the last example. Still solving triangles. Here we have a given 64 degrees. I would take a 90 minus that 64. That's going to equal 26 degrees. So theta is 26 degrees. We then want to find a y value there, an x value there. We're going to have to use trig functions to do that. So, again, I'm going to use the angle they give us. That's the 64. And in this case, sine of 64 equals x, the side opposite, over the hypotenuse, 12.4. We're going to multiply both sides by 12.4 to get x by itself. We would have x equals 12.4 times the sine of 64, which should give us something like 11.15, sorry. 11.15. That would be here. Now, when we got this 11.15 from the calculator, I believe it was actually something like 11.145, so we've actually rounded off there. So if we use the rounded value in the Pythagorean theorem, we're going to get round-off error, and it'll be a little bit different. I'm not sure if that matters to us or not at this point, but we could also use the cosine of 64 equals y over 12.4, and we have no rounding there. The 64 is given, the 12.4 is given, and so the y value will be a little bit more accurate, I think. That would be my preference. And I believe if we do it that way, we end up with 5.44. All right, so we have both of our sides and the angle we were missing. So at this point, you might want to take a look at the summary, answer those questions that are asked of you, and get that stuff set in your mind.